Welcome to the Building Doctor Show with Jens Johansson.
All right. Welcome to the Building Doctor Show. I'm your host, Jens Johansson. Glad to see you here to learn more about your buildings. Today, we're talking about earthquakes because it's Earthquake Awareness Month. So we're going to have a shaking good time. So if you're joining us on the podcast or YouTube today, thanks for listening, but you're missing out on all the slide content. We're going to have videos today. So if you'd like to have your questions answered live, be sure to visit our website at j2consultants.com to register for the Building Doctor Show and attend live via Zoom. So I hope all of you attending live have lots of questions because they help steer the show and make it valuable for everyone else. And so if you have a more specific question, stay tuned for a link and you can set up a quick free one-on-one call with one of our building doctors and we can answer your specific questions then as well. Our producer, Carolyn, will be monitoring the chat, and I'll go through the Q&A panel at the end of the show. We'll also be doing the raffle giveaway, so stick around for that to win some cool J2 stuff. So remember, this show is for educational content only. We're not giving legal or financial or engineering advice. So let's get started. Okay, today we're talking about earthquakes and how it affects the building and the building envelope, some preventive maintenance and earthquake readiness you can do to your building, both before and after a quake, retrofitting your building if you're interested in doing that, and some post-earthquake repairs and what to do after the shaking stops. We're also going to talk about insurance because earthquake insurance is it's a little bit of a different thing. So we're going to talk about kind of the pros and cons of it and why you should consider it. So, Earthquake Awareness Month. Hey, we're talking about Pacific Northwest and specifically West Coast. But the West Coast, we've got the Cascadia subduction zone. It runs from California up to BC. The Seattle fault is a pretty active fault, but it last ruptured around 1100 years ago. But the Pacific Northwest gets all sorts of earthquake activity, and we're going to give you today's results. The largest quake in the last year was a 6.4 magnitude earthquake off Vancouver Island. So kind of things to think about when you hear about earthquakes in the news. Damage to buildings starts happening around a 5.0 magnitude, but it depends because all earthquakes are different. They can be deep, they can be their shape or how fast or how up and down they go, and your building soils. And so we'll talk a little bit about that as well. So here is today's report. They happen every day. This is February 25th's report. We've had 38 earthquakes today throughout the world here, but the magnitude ranges from 2.5 to 5.9. And this comes off of a interesting pnsn.org earthquakes. And so you can see the daily earthquake report if you want to. The Pacific Northwest area, last 2 weeks, there have been 179 earthquakes with the largest of 5.3. So we're starting to get up there a little bit. And so this shows you all these where they're all happening. Bigger ones are referenced by the bigger symbol. And so, yeah, the magnitude. But lots over here in California. But you can see kind of this line. This is that Cascadia line that we were talking about earlier. Okay, why is this important? Here's a good picture of a great historic building down in downtown Seattle, Pioneer Square, Phoenix Underground. It was a popular nightclub, dance place, and also blues and various small venue for some cool acts. But it's an example of unreinforced masonry building. So think brick building. So we can clearly see the bricks. The building right next to it is also brick, but it's been painted. but I want you to pay special attention to these little bolts or washer heads that you can see going down the corners and at the floor lines. So these are reinforcing locations of basically a bolt with a washer and a nut on the outside to kind of hold that cladding in place. So this picture is a result of the Nisqually earthquake, and this caused a lot of damage in 2001. Here, the brick masonry just peeled off of the wall or fell off of the wall down to the street, damaging the awnings, damaging the cars, landing on the sidewalk. Would have seriously hurt someone if they were walking by. But I want you to understand or look how the roof is a horizontal diaphragm and the wall is a vertical diaphragm. So we attach those two things, but in an earthquake, your building is moving and these things can actually start bashing into each other and moving differently and start peeling off. And so you can see the level of damage is all across that horizontal intersection. And because the brick wasn't reinforced, like all historic buildings, you'll have this caving in and collapsing. So unreinforced masonry is the big thing to watch out for, brick buildings. And then we'll talk later about what buildings survive better or not. But this also gives some, the experts think we have, in the next 50 years, we will experience another significant earthquake. And Washington has the second highest level of risk in the United States. I didn't realize it was that high. So definitely something that we should be talking about and planning for. But again, the takeaway, look at the reinforcing on the building right next door, probably built almost at the exact same time, didn't have damage. Okay. So this is a photo from, you can see the brick has just peeled off and it's rubble all over the street. So this was back in 1965, I believe. And in the 60s there, and it was a 65, 6.5 magnitude. But this the screen shows us, in 95 we had a 5.0, in 96 we had a 5.3, in 99 we had a 5.8, in 2001 we had a 6.8, 2025 we've kind of bounced around in the ones, and and then we've had how many today alone. So they're not necessarily increasing, but this is just a pattern. They're always happening, and it's something you need to plan for and think about while running your buildings. Okay, so earthquake terminology. I'm not going to spend too much time on this, but this is that Benioff zone following the Cascades all the way up into BC. But we see here that kind of lines up with Puget Sound, and that's where we see the damage happening. You get out to the shoreline where you get these subduction quakes. You get the Juan de Fuca plate and the Pacific plate coming together and having lots of action. The subduction zones you'll get some bigger earthquakes out here, but they're off the coast a ways. But that's what causes the tsunamis. So you get the big earthquake, then you get some tidal action because of that. The Benioff zone has the lots of action in the damaging quakes there. Okay. Now, how we're going to talk about how earthquakes affect the building. And so we want to think about building materials. So wood frame has some good flex and bend. I'm holding up a piece of wood. I can bend it. It's got resilience. If I bend it too far, it'll snap and break. We don't see a lot of that in earthquake where the wood actually breaks in half. We just see a lot of the bending and then the components fall off. So the brick or the other things crack. Steel, here's just a little knife. Steel has a lot of flexibility. It can bow, it can bend and not break. But the biggest ones are the masonry, brick, and concrete. Brick has no flexibility. It cracks, right? Even with a little bit of movement, it cracks. So understanding how your building's set up, think of your building floors like boxes stacked one on top of another. And so in a shake, we want to keep those boxes together, keep them attached, so we don't end up with one box hanging off that side, another box hanging off that side. And then we also want to take that stack of boxes and tie it down to the foundation so that it doesn't slip off its foundation and kind of then tip over. So we want to tie it to the foundation, tie the boxes together, and tie the roof on top of that, whether it's a sloped roof or a flat roof. Tie those things all together. So as we're shaking and even going up and down, the pieces aren't bouncing and moving and shifting and all that. So a couple little diagrams here. And then earthquakes have their own little, wavelength and things like that. So you've got this side to side movement that will cause your tower to do this. Then you've got a vibrational, which are shorter waves, but it's just, really shaking it. And then you also have the up and down bounce, if you will. And so we tie those things together with these. The middle diagram has these triangular braces and supports to control some of that movement. And then if you really want to get fancy, you can do base isolation, where your base is, think of it like on rubber bumpers, if you will. And that'll allow the building to move and it'll minimize the sway. And so you got to think about that up front. Really hard to put that in at the end. But afterwards, we can retrofit to keep your building a little bit stronger and not moving as much. So again, earthquakes, depending on how they react, your building can be moving left, right, north, south, and up and down. And so who knows? So that's what a lower magnitude, but with lots of movement, may be just as damaging as a higher magnitude. Okay, so 2 reasons for damage. We've got that shaking in the horizontal, vertical, oscillating, bouncing, if you will. But then we also have what comes along with earthquakes can be landslides or soil liquefaction or even tidal waves and flooding. So soil liquefaction occurs when the soil itself is kind of loose and dry, but then because of all the shaking, groundwater can come into it, and then it turns into jello. And so you get this real mush feel. So that earthquake may be over and the shaking is stopped, but the foundation starts sinking a little bit. You start leaning. And so there's often damage that occurs well after the shaking is done. So these are some things, and you can, people can, or you hear stories of a Seattle regrade, which they regraded Seattle to kind of take some of the hills out and smooth it out a little bit. But that fill and compaction can make some soil liquefaction issues if there was a significant earthquake. Okay, are taller buildings safer? Well, taller buildings can flex more. Remember my longer piece of thing, I could flex it instead of a shorter 3-story building that's actually more rigid. And so these taller towers actually are absorbing a lot of the movement through the flex. And then you can see this is a San Francisco tower. Down at the base, we have this series of triangle or pyramid type things that really spread out the weight, but make a much stiffer foundation for this tall building. And it's built in San Francisco, so they were thinking about it. But the shorter the building, more engineering work needs to go into it because it's stiffer and it won't move as much. Okay, earthquake proofing. Well, I don't know if it can be proofed, but kind of 5 things. We can create a flexible foundation. We can counter some of these forces with dampening or, some kind of way to dampen the vibration or shake. We can shield the building from vibration. That's those isolators. We can reinforce the building structure. We can make it stronger, make it attached better. That was that unreinforced masonry where we can attach it. And then we can use earthquake resistant materials, and that's more in new design. So we're really looking at items 2 and 4. We can do some dampening and you can reinforce the building structure. And so, well, we'll get into a few of those slides, but when people come to us and they say, I want to do some earthquake, reinforcing, it's like, okay, well, there's a few ways to do it and a few of them are expensive. So how far do you want to go? And so we'll talk about that a little bit too. Okay, creating a flexible foundation. So this is a little video here. See, these are these isolators. And if I can build from scratch in an earthquake prone area, I can put these isolators below, and the building really isn't moving that much. The ground is moving, but those isolators take up the movement. So we basically have a special foundation that absorbs some of those shakes. Oops, I want to do that again. I'm going to go to the next slide. Then we can counter these forces with dampening or pendulum equipment. And so the building's going to move, but hydraulics will actually dampen or dissipate. And so it's very similar to shock absorbers used in your cars. They kind of help shock the tire help dampen the tire as it goes over the potholes. And so this type of hydraulic nature will help reduce that. And shielding the building from vibrations, more vibrational control. These are dampers and diagonal bracing. And so when you've got some hydraulic fluid that slows down the movement and doesn't let it whip out of control, and they're designed to work together. And so basically they ease the force on the building. This is retrofitting the building, and that's a common way to do that. Okay. More. And then I would say this is reinforcing the building structure. If you don't have this, like in older buildings, we would be putting in shear wall, so that diagonal bracing would keep the structure from turning into a house of cards and just tipping over. The diaphragm, remember the picture of the roof, the horizontal diaphragm. So again, plywood sheeted, and this shear wall, plywood sheeted, even some diagonal bracing. And then the moment resisting frames. So where the floor lines or joists come into the wall, really bolting those two things together and actually letting the studs flex and bend in between those attachments. And so playing this video, you can kind of see how these things move. And you can see that moment resisting frame, we're allowing the stud to flex, but the bolt and hardware are keeping it together. So this is really the most common retrofit. We're doing some diagonal bracing or shear walls. We're putting in additional diaphragms on roofs and floor plates, and then we're reinforcing any place you have these connections with good beams and hardware. And then basically earthquake resistant materials. We talked a little bit about this. Structural steel will allow bending without breaking. It might bend and deform and still be screwed up, but it won't break. Wood, again, has some flexibility. And then you have some fancy materials or original natural bamboo materials. That's why it's a good building source. But they can move and allow for movement and not break, unlike brick and unreinforced concrete. Okay, so how seismic forces stress the exterior walls. We're basically talking about cracks, fractures, and even delamination. And so we can get, obviously we're looking for, you can get lateral cracks in stucco, masonry, and siding. You'll get cracking in your interior finishes, and this is where some of the value of your earthquake insurance comes from. So if you have drywall is pretty cheap, but if you have plaster, stone, tile, that gets expensive real fast. So again, any kind of tile will crack, just like plaster, stone, or brick. Load bearing walls may develop big shear wall cracks, diagonal cracks from top to bottom, over 1/8 of an inch. Seismic movement can cause wall to foundation separation, creating gaps at base plates so things aren't tied down to their, again, the boxes aren't connected and the stack of boxes isn't connected to the foundation. So we can have some of the separation creating gaps at base plates. And then you can damage pre-existing weaknesses. So if your mortar between your brick is kind of toothed out and crumbly and old, it's really going to get damaged and not provide any good support. And if you have unreinforced masonry, CMU block walls, think like fire uh, your fire stations or your schools. There's a lot of the CMU block, the concrete masonry unit, and a lot of brick, and so that stuff won't flex. So before and after, before, you're going to be inspecting your exterior walls for cracks. You're going to be looking for diagonal cracks near doors and windows. You're going to be looking for vertical cracks in stucco. We suggest doing kind of a tap test in the stucco or siding. If it sounds hollow, detachment may have already happened. So it might just be there hanging on, but it's delaminated from or become detached, or the attachment has actually failed. So behind stucco, you have wire mesh that's stapled into the wood. If that's pulled out, that cladding can fall off. You want to check your brick and masonry for loose sections. If the mortar's crumbling, the wall may need to be repointed or even braced. You want to seal small cracks immediately. You don't want extra water to get in there and cause more freeze-thaw damage. And then if you have major cracks bigger than 1/8 of an inch or growing, call in an expert and have a structural assessment. Windows and doors. So windows and doors, misalignment happens. So my wall where I have a square window kind of turns into a trapezoid, or my floor to wall kind of experiences some up and down, and now the doors don't open. They hit the flooring, and they didn't used to. So we'll get some kind of movement on those door or window frame openings. We may have some pressure from some stress, which may jam some of the doors and cause windows to stick. The windows themselves, the glass can break, or the frame and the glazing unit, the IGU, actually twists and can even pop the insulated glazing unit, and that results in your fogged panes when moisture gets in between the panes because the window pane has gone under distortion and cracked. So maybe the glass isn't broken, but all of a sudden after the earthquake, all my window panes are fogged up, and it's like, had a lot of movement on the windows. So look for that. And then weak anchoring or weak attachment to the windows can actually pop out of the frame. What do I mean by that? Retrofit windows where the nail fin's been cut off and they've been caulked in place, and you're lucky if you have a nail in each corner. They're designed to be attached every 4 to 6 inches around the perimeter, not with lots of fasteners, not just 4. And so that window can actually pop out of its opening or get loose. So you want to be checking those things. Okay, so again, before and after. Before, test all your exterior doors and windows, and if they don't operate smoothly, fix them. But then, of course, after the quake, if they don't operate smoothly, things may have shifted. You're going to be looking for glass damage, but it might be these weather stripping and sealants that have failed, and water can get in, or those thermal units can fog. Again, window flashing and anchoring, if they feel loose, they are, so you might need to reinforce them or replace them. And then if you have some serious issues where things are a triangle that they used to be a square, call in an engineer and have a greater evaluation done. So your roof and waterproofing damage. Remember our first picture, the wall had fell off and took half of the roof with it. And so that type of damage can damage the roof membranes. They can rip, they can tear, they can cause sealant failures. That shaking can dislodge tiles and shingles and parapets, creating fall hazards and holes in the roof. The vibrations can crack coatings and roof membranes, so make sure you inspect after, looking for places where water can get in where it couldn't use to get in. And then also check drainage systems. So we'll see downspout lines get dislodged or get blocked underneath the ground because of ground shifting, and things don't quite work like they used to. They didn't drain like they used to. Now we have standing water and maybe a bigger problem on our hands. Okay. So inspect the roof edges and flashings, look for lifted tile, check your roof membranes and coatings, look for missing shingles, inspect all your parapets and roof mounted equipment. So you might have some HVAC equipment up on the roof, and that might not have been bolted down right and fell off. A lot of those things have gas, they're gas powered. So if we have some shifting up there, the gas lines, make sure you check that. Check the electrical connections. Obviously, if the unit tipped over, it probably ripped the wires out and might be a electrical hazard. And we're checking those drain lines. Okay, so cosmetic damage, we're talking about small stucco and drywall cracks. We're talking about minor mortar separation in the brick and stone. We're talking about paint chipping and bubbling. Okay, that's a small earthquake, got a small, we got some issues. We got to deal with it. It's going to cost money. We'll get into that insurance coverage later. Obviously, structural damage, really urgent. We've got big cracks. We've got diagonal stair step patterns. We've got gaps at the roof to wall or wall to foundation areas. We've got windows or doors that won't open. I can't get out of the unit. Maybe people are locked inside, or stuff doesn't work. Obviously, look for visible tilting or collapsing, whether the walls or floors or anything like that. And then again, if you have an exterior masonry like brick, is it hollow? I've literally been able to push on the wall and you can see the wall just kind of move, and it's like, whoa, this is going to fall over, either under its own weight or with an aftershock, it's done. So really making sure, look around. So before and after, make sure you document everything, take photos immediately, monitor for worsening conditions. Again, a lot of that damage continues. The building has shifted, the soil maybe has changed, the weight, the building hasn't fallen over, but yeah, we're cracking, we're making noise, it's groaning. And so we want to document all that and make sure we capture that. We want to seal any kind of minor cracks, or keep the water out. Obviously triaging or prioritizing structural problems, and then making sure, again, we've talked about water intrusion after an earthquake can cause secondary damage. And then one thing I mentioned it a little bit, but turn off your gas pipes, turn off your gas mains right after the earthquake. If you go out to your gas main, you'll see a kind of a square, it's kind of a long knob that you can grab onto, and you can actually align these two plates, and there's a hole in the middle. What that's for is when you don't pay your gas bill, they twist it and put a padlock through it, so you can't turn your gas back on until you pay your bill. And so that's how you know it's off. And then you can smell natural gas. It smells like rotten eggs. So you can kind of walk around the building and just kind of, what smells in here? I might have a gas leak. I got to call the gas company and we got to check that out. But having, any kind of wrench, a crescent wrench will do it. They make special plastic wrenches, so there's no static electricity. Having that wrench maybe wired to your gas main, just I know where it is. I can grab it and quickly turn the gas off in the case of an emergency. So then we are, for preventative, we're obviously inspecting again. We're strengthening any problems. We're ensuring that we don't have any water leaks. And we're checking things like fireplaces. We're checking chimneys. We're checking brick facades. So back to our 5-story wood frame condominium, or 1-story, 2-story, 3-story, whatever. It's wood frame. It's probably done okay. It's flexed. It may have, shooken a little bit. It might have drywall cracks. But it's those masonry chimneys or any kind of the stone cladding out front. Is that falling off? Is that having issue? And of course, if I live in an older part of town with lots of brick buildings, I'm really concerned about the brick. And so again, just making sure we're taking care of it and making sure things are properly maintained, the masonry is in good shape, etc. So over to the retrofitting. We'll talk a little bit about, hey, I've got an old building, I want to retrofit. What do I do? And so bracing and strengthening, we're probably not going to dig under your foundation, put those fancy isolators, but we want to really pay attention to, again, unreinforced masonry, stucco or some kind of concrete, and then chimneys and parapets. Parapets are the portion of if your roof is here, it's that wall that comes up kind of about 3 feet to give you protection when you're on the roof and you don't fall off, but it makes a nice part of the facade of your building. And we want to make sure that isn't loose and flapping. So here's some examples. This first one on the left is a pretty extreme example, but it's actually bolted on to the outside of the building. So here's this big steel frame, diagonal bracing, but it's worked into the shape and aesthetic design of the building. And so it's obviously a very rigid looking structure. The right photograph is that big diagonal shock absorber, if you will. So if you have an office job and on your floor you see these funny diagonal pistons, these are those shock absorbers or stiffeners that are keeping your steel, skyscraper and steel and concrete, keeping it rigid. But that's, the first time I saw one in person, I was like, what is that? Oh, there you go. That's how they keep it together. But the most common way is, again, in these brick buildings, here's these washers or plates, they call them, plates and nuts, but they go back through the building to a big bracket that's bolted on the beam. And these plates just give this whole brick wall some stability. And they'll be small washers, they'll be bigger, kind of dinner plate size, and they can even be kind of 2x2 plates or even steel bands. If we're trying to design it, we're going to design in some, it looks aesthetically nice. Or maybe these washers are more of an ornate. They look like some kind of coin or some kind of, they have a little pattern to them instead of just a steel washer that rusts. But what these brackets do, again, keep the brick from falling off. So on the inside, here's our old wood, plaster, concrete, but you can see the red iron or steel is big steel brackets bolted into this to really tie the structure together. And if we can't do that, then we'll be doing some of these brackets, or kind of think of it like a little Tinker Toy set. And then we have to enclose that into drywall and protect it, but also kind of hide it. And so you now have some funny little bump outs or columns or things like that, but your steel brackets and seismic retrofit stuff is in there. So you can Google, you can say, show me earthquake seismic retrofitting, and you'll see all these things. But this is what we're talking about. Okay, so flexible materials is one more thing in what we're talking about here is sealant and expansion joints, keeping your building, giving it a little bit of rubber bumper and a little bit of weather stripping to move well. Expansion joints can control movement, but they need to be maintained. It's one more thing to do to keep the water out. And okay. So retrofitting for doors and windows. Again, we kind of talked about this, but you really want to be focused on the older frames, the older wood or aluminum. Again, think older buildings. So historic part of town, brick and wood frame windows. The wood tends to break and warp and all that stuff. Instead of metal or vinyl, plastic would have a nice bend to it as well. Then the roof safety measures. Don't forget about skylights, rooftop equipment. We talked about that. Parapets and decorative facades, things like that. Just keeping those in good shape. The post-earthquake repairs, we're going to be kind of triaging lots of damage to just cracks, and then deciding whether we want to call our insurance company, companies and repair funding. So we're going to talk about that. Okay, so insurance coverage. So earthquake insurance provides coverage if an earthquake destroys your building, destroys your home. It can be a separate endorsement that you buy and add to a policy. It can also be a standalone policy. And there's actually an extra little thing called a change of condition policy that may also have some earthquake coverage. What it means is after the event, was there a change in condition? Yes, my chimney had fallen over. It used to be vertical before the event, and now it's horizontal after the event. It's a change of condition. So you might have some earthquake coverage there. But what we typically see are deductibles equaling 10 to 25%. And again, all insurance companies are changing things every year, and we see higher and higher deductibles. So make sure we're looking at that. But for math's sake, so if you had a 20% deductible on your structure's policy limit, and so here's where it gets confusing. So if I have $100,000 policy, a 20% deductible is $20,000. That policy will not start paying until once I get over $20,000. So I may have a $25 million policy with a 20% deductible. So that's a $5 million deductible. So $5 million pays for a lot of drywall cracks, right? And so we have to kind of look at that and say, is it worth it? And so this is where you really want to get some help from a broker to help understand this. But you may also have separate deductibles for contents, unattached structures like garages, sheds, driveways, spa, verandas, things like that. And you obviously can't buy it after the earthquake. So we're going to cover, we may cover, and then not cover. So we're going to cover, this insurance policy will cover repairs to your building, damage to your property, cost to remove the debris, and usually additional living expenses, or ALEs you might have while your home is being repaired or rebuilt. So that's the hotel expense for me living in a hotel while my building is being repaired. It may cover increased costs to meet current building codes, but you got to watch for that. Does this include code upgrades? Does this pay for the retrofitting that I want done now that my building's really, gotten damaged? And/or stabilizing the land under or around your house. Maybe there was a landslide in the backyard and I've got to deal with that. Does my insurance policy cover that? It may cover other structures not attached to your house. So again, sheds, garages, carports, things like that. Make sure, or just think about, an open metal carport, steel metal carport will probably move quite a bit and not have a whole lot of damage, where your building is going to have a lot more cracks and things like that. Okay, it won't cover fire. And this is an interesting, in most of the things I've seen, in earthquake insurance does not cover fire, even though the earthquake caused the gas main to rupture and caused gas leakage and that led to a fire. And so your earthquake coverage will pay for the damage. Your regular policy will pay for the fire. So it's also not going to cover land, vehicles, pre-existing damage, external water damage, damage due to landslide settlements, mud flows, earth rising, earth sinking, or contracting. May not even cover floods, tidal waves, tsunamis, even when caused by an earthquake. And so here's where you get into, and it's more flood insurance, but it's how these policies will pay for themselves. So the earthquake caused a tsunami. The tsunami did all the damage to my building because it was a flood or a tidal wave, but the earthquake policy doesn't pay for that. And so make sure you can connect the dots between the events when you're reading when you're reading the policy or when you're reviewing that policy with your broker. So if the earthquake causes fire, is the fire covered under this policy? Yes, no. If the earthquake covers flood, is the flood covered under this policy? Yes, no. And so, like I said, every policy is different. Every company's a little different. All these, they have their nuances, but we put it in the not cover because we've seen more than less. So landslides, hillsides, do you live on a hillside? Are you going to earthquake and slide down the hill? So those are things we got to think about. So as in a nutshell, we say earthquake insurance can be questionable, even when the damage from an earthquake is less than the coverage limit, because the high deductibles typically associated with these policies, meaning if the damage is below the deductible amount, you won't receive any payout from the insurance, even if the damage is significant. So that the damage has to exceed that 20% of my policy limit in order for me to receive $1 of earthquake coverage. And so if I'm in a wood frame structure and I know I'm going to have drywall damage, I don't have any tile, I don't have any stone or brick or chimneys or anything like that, I'd kind of, do I want to pay extra for the earthquake coverage or not? And so it really kind of gets down to a business decision here. So key points, again, percentage basis of your total policy. And so if it's 5% of your policy, that's one thing. If it's 30% of your policy, it's totally another example. So here's, a $700,000 policy. You need to have $175,000 worth of damage before it pays $1. So talk to a good insurance broker and to get that right level of coverage. So here's, the high deductible. They obviously have lower costs. It's kind of that catastrophic policy, if you will, but it's a super benefit in a major damage scenario. And so we get earthquakes every day, and we've had big ones, and they've destroyed lots of stuff. But is it going to be worth your time and valuable given your building? So that is that business decision. So that type of building structure, wood frame will fare better, masonry or brick, and then is it new masonry and new concrete or versus old? Old stuff will have a lot more damage to it. We have our old brick ties that are folded pieces of metal that go in between the bricks and they get nailed onto the wood sheathing. And over time, those rust and fail. And so if they're 60, 80 years old, they're all rusted out anyway. So even though it was originally reinforced, it's not anymore, not now. And so that earthquake will cause bigger problems there. So the level of deductible for the amount of damage you expect, the costs of retroproofing or retrofitting versus the costs of damage or repair versus the risk of a big earthquake. And so retroproofing is not cheap. You can see we have to really get into the components of the building. We got to connect those beams. We got to pull the drywall off. We got to really fab this stuff up. It's lots of engineering, lots of welding, lots of custom fabrication. And so if we do that, are we guaranteeing no damage? Well, it depends on the size of the earthquake. And so in some cases, it makes lots of sense. In other cases, it doesn't. So, and then if you have lots of finishes like stucco, plaster, tile, those are all very expensive. And oftentimes it's not just, it's that one crack in the middle of the wall, but I have to skim coat or paint or custom plaster finish the whole wall, corner to corner, floor to ceiling. And so one little 12-inch crack, I've got to redo the whole wall, or I got to redo the whole ceiling. I can't just take a tube of caulk and, you'll see the crack and you'll see the fix. So the patching can get expensive with those types of finishes. So we recommend earthquake insurance for masonry buildings and buildings in earthquake prone zones. And now you, as a board or group of owners, need to get together and say, what makes sense for us? Let's talk to an insurance rep or broker and see what's happening there. All right. More questions or need inspections around earthquakes? For those of you who don't like to type, just take your phone out, scan that QR code. For those of you who do like to type, learn.j2consultants.com/consultants-on-call.
This podcast is part of J2's free live webinar, The Building Doctor Show. To attend the live show and ask your questions during the Q&A, visit www.j2consultants.com.